Hello friends, welcome to this video. Today in this video we will study about the surface area of sphere and hemisphere. Thomas, look what I have brought for you today.
This looks so beautiful. What is this, Manas?
Sweets from my sister's wedding. You know, Manas, this sweet is completely coated with silver.
Oh wow! How much silver would have been used to cover it?
We can find the answer to this through mathematics. That means it's math time!
Manas, this sweet is circular, isn't it?
No, Thomas. This is a sphere.
Now, what is this sphere?
Thomas, just like a circle is a two-dimensional shape, a sphere is a three-dimensional solid shape, which is made up of all those points in space which are at a certain fixed distance from a certain fixed point. This fixed point is called the center of the sphere, and the fixed distance is called the radius of the sphere.
Alright, I understood about the sphere, but how will we find out the amount of silver used to cover this spherical sweet?
The silver is completely covering the total surface of the spherical sweet. So we can say that the silver used to cover the spherical sweet will be equal to the surface area of this sphere.
You're right. But how do we find the surface area of the sphere? We do not know its formula.
Then let us find the formula for the surface area of a sphere. Suppose the radius of this spherical sweet is r. Now imagine if we wrap a string on this sphere in this way and keep wrapping it on the sphere till it covers the sphere completely. Now on a paper, if we make 4 circles with radius r of the sphere in this way and fill the circles by placing the string we had wrapped the spherical sweet with one by one, then we will find that the string which completely covered the surface of the sphere is now filling the surfaces of 4 circles with same radius as that of the sphere. Can you tell me what this means?
I get it. This means the surface area of a sphere with radius r is equal to the area of 4 circles with radius r, and the area of a circle of radius r is pi times r square. Oh wow, Manas! We found the formula for the surface area of a sphere. The surface area of a sphere is 4 times pi r square, where r is the radius of the sphere.
Well done, Thomas. But what are you thinking now?
I am thinking that I will surely eat this sweet by sharing it with you. But if we cut it into 2 equal parts, what will this new shape be now?
Thomas, if we take any solid sphere and cut it into 2 parts by passing a plane through its center, then it will be divided into 2 equal parts, and each half of this is called a hemisphere.
Now, what will be the formula for the surface area of this hemisphere?
I will tell you. First, you tell me how many surfaces are there in this hemisphere?
2. one is curved and the other is flat.
That's correct. The area of this curved surface is equal to the curved surface area of the hemisphere. As you can see, the curved surface area of the hemisphere is half of the surface area of the sphere. That is, the curved surface area of a hemisphere is equal to the product of 2 pi and r square, where r is the radius of the base of the hemisphere.
And look, if we add the area of the flat surface to the curved surface area of the hemisphere, then we will also know the formula for the total surface area of the hemisphere. In this way, the total surface area of the hemisphere is the product of 3 pi and r square. Let me quickly write these formulae in the formula booklet.
You forgot all about your original question in the whole sphere and hemisphere discussion. Come on, now quickly find out how much silver has been used to cover this spherical suite.
Oh yes. I will solve this quickly by writing the radius of the spherical suite. 3.5 centimeters instead of r in the formula for the surface area of this sphere. Look, this spherical suite has been covered with 154 square centimeters of silver.
Well done, Thomas. Now let's quickly return to our world and eat this sweet by dividing the sphere in half. The two friends enjoyed eating the sweet by dividing the spherical sweet into halves. In this video, we studied about the surface area of sphere and hemisphere. We learned 1. What is a sphere and hemisphere? 2. How to find surface area of sphere and hemisphere. In the next video, we will see some interesting examples based on this. Hello friends! Welcome to this video. In the previous video, we studied about the surface area of sphere and hemisphere. Now, in this video, let us look at interesting examples based on the surface area of sphere and hemisphere.
You have made very beautiful models of the moon and the earth. The moon and earth are both spherical, right?
Yes, Thomas.
But Manas, have you used more clay to make the model of the earth or to make the model of the moon?
I don't know, Thomas. Why don't we find the answer to this through mathematics? That means it's math time! Look, Thomas, the models of both the moon and the earth are hollow spheres. The radius of the moon's model is 35 centimeters and the radius of the earth's model is 140 centimeters.
I remember the formula for the surface area of sphere. The surface area of sphere is 4 times pi r square, where r is the radius of the sphere. And because both of these models are hollow spheres, the amount of clay used to make them will be equal to their surface areas. Let me solve this by writing the radius of the moon's model 35 centimeters instead of r first. Manas, the surface area of the model of the moon is 15,400 square centimeters.
Okay, now it's my turn. I will solve it in this way by writing the radius of the model of the earth 140 centimeters in the formula for the surface area of the sphere. Look, the surface area of the Earth's model is 2,46,400 square centimeters.
The clay used in the model of the Earth is many times more than the model of the Moon.
And do you know another fun fact? If we find the ratio of the clay used in the model of the Moon and the clay used in the model of the Earth in this way, then you can see that their ratio is 1/16. And in fact, the ratio of the surface area of the Moon and the Earth is also 1/16. Isn't it amazing?
It is. This is really interesting. Let us quickly return to our world. Then you tell me more information about the Moon and the Earth.
With this example, we have seen how our daily life problems can be solved based on the surface area of the sphere and hemisphere. In the next video, we will see some more interesting examples based on this. Welcome to this video. In the previous video, we saw an interesting example based on the surface area of sphere. Today, in this video, we will look at some fun examples based on surface area of hemisphere.
Manas, let us go to the fair.
No, I will not be able to come. Mom has asked me to get these bowls galvanized from the utensils shop.
Good. What will be the cost of getting galvanization done on these bowls?
I never thought about it. The shopkeeper charges 5 rupees per square centimeter for galvanization. But how do I find out how much it will cost to get these 2 bowls galvanized?
We can find the solution to this through mathematics. That means it's math time! Look, every bowl is a hemisphere. And because we have to get the inner surface of each bowl covered, the surface of each bowl will be equal to its internal curved surface area.
Oh, is it? I can easily find this. These 2 bowls are exactly the same. So, their internal curved surface area will also be equal. The bowl is a hemisphere and has an internal diameter of 14 centimeters. This means the internal radius of each bowl is 7 centimeters. But there is a problem. I do not remember the formula for the curved surface area of the hemisphere.
Oh, this is very easy. Let me show you an easy way to remember this. These bowls are hemispheres, and every hemisphere is half of a sphere. Therefore, the curved surface area of hemisphere will be equal to half of the surface area of a sphere. That is 4 pi r squared divided by 2. In this way, the curved surface area of the hemisphere is a 2 pi r square, where r is the radius of the hemisphere.
Oh yes! Thanks, Thomas. Let's solve this by writing the radius of the bowl 7 centimeters instead of r. The internal curved surface area of the bowl is 308 square centimeters.
That's right. And you have 2 such bowls. This means you have to get a total area of 2 times 308, that is 616 square centimeters. Now we just need to multiply the galvanization rate per square centimeter, 5 rupees, by total surface area to be galvanized, 616. Look, Manas, it will take a total of 3080 rupees to get the galvanization done.
Oh God! So much money! It was good that you told me, Thomas. I was going to the shop only with 100 rupees.
Let us return to our world now. I will quickly take you to the market on my bicycle. After that, we will both go to the fair.
Friends, in this video, we saw a fun example based on the surface area of hemisphere. We hope you have a good understanding of the surface area of sphere and hemisphere now.